we're going to look at S-CP.A.1 worksheet number 5, and it has a lot of the same kind of stuff as number 4 did. So if you're a little lost here and didn't watch that video, I'd go back and watch that as well. Here I'm going to kind of focus on the words and a little bit about shading to understand what's going on in the Venn diagram. So the probability of A means all things that could happen to have success of whatever event A is. It could be getting an even, it could be whatever. But in a Venn diagram, that would be represented as everything inside of the boundary of A. Notice that there's a little bit of B in there, but that's okay because there are some overlap, okay? It's still all a part of A. The probability of B would be all things inside of B. So this is the proper shading for this, everything that's inside of B. Now we talked about this. The little c means the complement. And the key word for complement is not. This is stuff that is not in A. So you have to think about that. All right, anything in that oval shape is in A. So if I was to shade the things that are not in A, I would shade all of this region right here. Do you see how everything that is outside of that boundary got shaded? And you say, well, do I shade this little part? No, that's in A. It's in B as well, but it's in A. So it's everything outside of that. If we're shading everything outside of B, we would shade all of this region. This is the stuff that's not in B. Not in B. So one thing I didn't mention, I guess, is if you have the probability of B and you add it to the probability of not B, you get 1, because think about that. If you have a probability, whatever it is, of B, and then you're saying add it to the probability of not being the B, it's everything else. So together, the two of them make one full whole, right? And think about it. The probability of B, that oval region there, added to that region would be the full box, right? The whole probability. Now we learned A means and means the intersection. The intersection. And it is what is in common in the two of them. So what's in common is just this region. That is the intersection, what goes on between the two of them. Or we learned is the union of them. Union of the two. It is what is the total of the things together. So it's the probability of A or B. So it's all of that region, everything in those two boundaries, because it's A or it's B. It's like getting a red marble or the green marble. You just combine them together. Okay? Now, there are a couple of other regions that are a little bit trickier, so let me get to those right now. And I'm going to write it in words. So where's the probability of A and not the probability of B? Or in other words, the probability of A intersect with the probability of not B. Now this looks pretty crazy. It's not that bad. So let's talk about this. Now remember, the and means what's in common in the two of them. So I'm going to take the probability of A, which is this region, and I want to know what's in common with the probability of not being in B, which is this region. You see that? There's the probability of A. Here's the probability of B, not B. What's in common between those two? What is overlapping in those two? It's actually not too bad. Think about it. The probability of A looks like this. And the stuff that is not in B. So when it's an and, it's the intersection of the things in A and the things that are not in B. So it has to be in A, and it can't be in B. So that becomes this region here. This is the part that's in A, and not in B. Now, a similar guy gets put up here and looks like this. This is the group that is in B, intersect with the stuff that is not in A. This is the stuff that's in B, right? It has to be in B, and it can't be in A. So here's the stuff that's in B, all of that whole region, and the stuff that's not in A comes out and looks like this. One last little thing, these are quite a bit of fun here. You've got 50 students that are being surveyed, and 25 of them are in the board game club. What a great club, the board game club. And 15 of them are in the math club. The math club, that's a cool club to be in. And 10 are in both. Now, you might say, well, you know, how many are only in the math club? Or how many are in the math club or in the board game club? So let's draw a little Venn diagram. This is where we'll finish up. Here's the board game club. Here's the math club. And we have 10 in both. Now the intersection is always important to do first because you got 10 that are in both clubs. That leaves 15 that are over here because 15 and 10 make 25. In the math club, there's 10 that share the clubs and 5 only in the math club. Now so let's run through some quick questions about this. What's the how many are in the board game club? The board game club, well, there are 25 of them. How many are only in the board game club? There's 15. They're only in that club. How many are only in the math club? There are 5 of those. And how many are not in the math club or in the board game club? Now, maybe we should find out how many are in the board game club, or in the math club. How many are in there? Well, we got 15, 25, 30 of them in there. Now let me tell you a common mistake. Some people say, oh, if you have 25 in the math club and 25 in the board game club, there are 30, 40 of them. That's not true, because some are getting double counted. There is only 30 in the board game club or in the math club. So if there's 30 there, that means there are 20 students that are not in either of those clubs. So a lot of connecting now the words to the game, right? Only B is of course B and not A. Only so B not M, and then this one is M and not B, and so on. The intersection is the group that is in the board game club and in the math club, and so on. So you get used to the verbiage a little bit.